Okay, welcome to my lesson on the top 10 mathematicians. This is meant to be an introduction to the history of mathematics, and I adopted the list from M.R. Sexton, 2010. The first thing you'll see on my title page is something that I created using infographics. It's just a nice little graphic that kind of displays the overall theme of my presentation. Let's go to the first page. Pythagoras of Samos. He was known as the father of modern mathematics and lived around 570 to 495 BC in Greece. He was the founder of the Pythagorean cult, which was a group of scholars that were the first to actively study and advanced mathematics. Pythagoras is obviously credited for the Pythagorean theorem, but some say that it was actually one of his students who should have received the acknowledgement. The Pythagorean theorem has played a large part in modern measurement and technical equipment through the use of right triangles. Pythagoras was very important to the development of geometry and the study of mathematics as a worthwhile endeavor. The next page illustrates the Pythagorean theorem. On this page, students can click here to investigate the Pythagorean theorem. They'll be given some slides that can manipulate this triangle that really illustrates the Pythagorean theorem. Number 9 on our list is Andrew Wiles. He got his start in mathematics as a young Einstein impersonator. Just kidding, I was looking at his picture and he kind of reminded me of Einstein, how he had the crazy hair. Actually, he was best known for his proof of Fermat's last theorem. You will investigate this theorem on the next page, so I won't ruin the surprise by telling you what it is. He was born in 1953 in Great Britain and is still living there today. The story goes that he basically locked himself in his attic for 7 years in order to formulate the solution to Fermat's last theorem, even though he was married and he had kids. Then, when it was found that his solution contained an error, he returned to his fortress of solitude for another year before the solution was accepted. On the next page, there are a series of just self-quizzes, and it's just illustrating that Fermat's last theorem, it just says that A plus B equals C will work for many different triples, so all of these will work. If you use A squared plus B squared equals C squared, only a few will work. B and C will work in this case, and those are illustrations of the Pythagorean theorem. And any higher power bigger than that, like A cubed or B cubed, does not have a solution. Number 8, we're sharing number 8 with Isaac Newton and Leibniz, and you'll see him on the next page. Everybody knows the story of how Isaac Newton was hit on the head by an apple and he said they discovered gravity, but he was best known for his laws of motion, and he lived from 1642 to 1727 in England. So Wilhelm Letsch was born in Germany, and other being known for his gorgeous curls, he was also well known for his contributions to what would become our first computers. He also introduced modern standard notation and made considerable contributions to topology. Number 7 is Leonardo Fibonacci. He was born in Italy but spent his childhood in North Africa, and as an adult, he spent most of his life traveling the Arab world and bringing their ideas to the Western world. The Fibonacci series, which has become an important part of biological sciences, was known to Indian mathematicians since 200 BC. Leonardo Fibonacci shared this idea with the rest of the world. He also contributed greatly to the introduction of Arabic numbering, which is the system we use today, that replaced the Roman numeral system. You will get a chance on the next page to try some of these examples. One thing that I want to point out here is that students can view a hint, so if they've forgotten what the Roman numerals are, there's a little aid there. And then, of course, this one would be the number 7, so they can just type in 7 and check their answer. And hopefully it tells them that it's right. Oh, they have a little check mark up there, shows that they're right. And then there's some other examples here on the page. Let's move on, though. The Fibonacci sequence. Notice how 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, and 5 plus 8 would be 13. Check our answer, and we got it correct. Okay, number 6 is Alan Turing. He was born in 1912 in Great Britain, and he was best known as a computer scientist and cryptanalyst. Of course, cryptanalysts are people that analyze codes, and he was best known for his code breaking that eventually aided cracking the German Enigma encryptions, which helped them win World War II. As a computer scientist, he developed the Turing test that is used to evaluate the computer's intelligence. In his spare time, he also tested an early chess program by playing the part of the machine. Number 5 is Rene Descartes. He was not only a mathematician, but also a physicist and philosopher. He provided the foundation for modern calculus and developed Cartesian geometry involving the XY plane. His contributions made it possible for mathematicians and engineers to calculate distances between 2 points without the use of a measuring device. He also introduced the use of superscripts to express powers. You can investigate the main points of the Cartesian plane on the next page. So on the next page, I've just created a little activity where students can hover over different parts of the Cartesian plane, and it just tells them the different parts. For example, the x-axis and the y-axis. And down here in the middle is our origin. And then I just hit a few points. Here's the point 20. There's another one out here somewhere that they can hover over. And it just kind of shows them some points. So they can just kind of investigate that a little bit. Okay, let's go on to the next page. Euclid lived around 300 BC in Greece and is known as the father of geometry. He was the author of Elements, one of the greatest mathematical works in history. He is credited with the construction of logical proof of theorems and conjectures. So for those of you who remember writing proofs in high school geometry, you can blame Father Euclid for that. On the next page is just a quick example of the start of a proof. We're not going to prove anything. I won't torture you with that, so I'll move on to the next one. Number 3, Bernard Riemann. And he actually, there's a reward offered, a $1 million prize for anyone that can solve the Riemann hypothesis. And it's an extremely complex problem on the distribution of primes. And since primes are used in codes, anyone that can figure this out is going to really help with the advancement of code breaking. Riemann was born in Germany to a poor family, and he lived to be 40 years old, but for most of his life, he didn't get any credit for what he did because most of the mathematicians of his day didn't really understand what his mathematics was. So he didn't get credit for it until after he was deceased. On the next slide is just a picture of the Riemann hypothesis, and this is the problem that you can solve and get $1 million prize. Okay, I think we're at number 2. Number 2 is Frederick Goss, and he actually has one of my favorite stories of mathematics. And I have a video on the next page. Basically, it tells about how when he was in elementary school, his teacher assigned the class a long problem of adding the first 100 numbers by hand. And he figured out a quick way to do it and surprised his teacher. And he was had a very outstanding mathematical ability. He proved the fundamental theorem of algebra and introduced Gaussian gravitational constant in physics before age 24. He also developed the bell curve, or normal curve, used in statistics. So here's where they can click on to get the video. It's actually a really cute video. And then number 1 is Leonard Euler, and he is known as the greatest mathematician ever, and he was born in Switzerland in 1707. His primary contribution was the introduction of mathematical notation, such as functions, trigonometry, logarithms, sigma notation, imaginary numbers, and pi. He continued to develop calculus, topology, number theory, analysis and graph theory. He also was well known for solving the 7 bridges of Königsberg problem on the next page. Now, I say solving, but actually, he just proved that it couldn't be solved. So there's no $1 million prize for that. And on the last page of my lesson, I just have a picture of what the Königsberg bridge problem would look like and how it was introduced. So this has been my lesson on the top 10 mathematicians, and students would then choose a mathematician of their choice, either from my list or another one, and write a 1-page paper, and that is outlined in a different format. So thank you.